Alright, our focus in this video is to solve quadratic equations. It's also known as finding the solutions or the roots or the zeros. So the idea is we are looking for where, if any, the quadratic or the parabola crosses the x-axis. So we're searching for where is y equal to 0. Alright, that's why they're called zeros. So we're going to look at 5 different methods that we could potentially use to solve quadratic equations. So the first one is to factor. You're not always going to be able to factor a quadratic, but if you are able to, you certainly want to use this technique. It's probably the easiest one to use. So here's a quick example. X squared plus x minus 6 equals 0. If we're going to solve this quadratic, trying to figure out where is it equal to 0. Well, we can factor x plus 3, x minus 2, and then you set each factor equal to 0. You get x equals negative 3 and x equals positive 2. So from there, typically we put these into a solution set. These are solutions or roots to that equation. Okay. The next one is to use the quadratic formula. And I mentioned before that this is given to you in your formula packet. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So here's an example. X squared plus 2x minus 5 equals 0. Notice that this is not factorable. So we go to our quadratic formula. X is going to equal negative b, so that's negative 2, plus or minus the square root. B squared will give me 4 minus 4 times a times c, okay, all over 2a. So 2 times 1. So let's clean this up. Negative 2 plus or minus. Be careful underneath your square root. There's 2 negatives in there multiplied together, so that's going to give you 4 plus 20. So that's going to be radical 24 all over 2. And if you break down radical 24, it's radical 4 times radical 6, which is 2 radical 6. So negative 2 plus or minus 2 radical 6 all over 2. Take it a step further. You can divide 2 into each of these terms. So negative 1 plus or minus radical 6. Now these are known as exact solutions. Jot that down, please. Sometimes a question will ask for the exact solutions, or the exact roots. If we wanted an approximate solution, well, if we were to do negative 1 plus radical 6, and suppose I'm going to use the approximately symbol. Alright, negative 1 plus radical 6, if you were to punch that into your calculator, you're going to get 1.45. And if you were to do negative 1 minus radical 6, you're going to get negative 3.45. Again, I'm rounding to 3 sig figs there. Okay? So that's a quadratic formula. Alright? If a question does not specify, you can either leave it in exact form or make it a decimal, 3 sig figs. Okay? Alright, so let's go on to the next one, which is complete the square. So CTS for complete the square. So here's an example for us. X squared plus 8x minus 3 equals 0. Now this is not factorable. We could use the quadratic formula on it, but I want to show you how we could use complete the square to solve for x. I think you might find it a little bit easier than the quadratic formula. So complete the square says we're going to write down the first 2 terms. We're going to divide this 8, that so-called b, by 2 and then square it. So 8 divided by 2 is 4. Square it, I get 16. I'm going to bring down this minus 3 from up above, and then I'm going to subtract 16 to balance out what I just did. Well, from there, I can factor this into two identical factors of x plus 4, right? So I'm looking to factor the trinomial part of this. So that is going to be x plus 4 times itself, so x plus 4 squared. And when I combine negative 3 and minus 16, I get minus 19, and then this is still equal to 0. Well, from there, if I were to add over 19, I have x plus 4 quantity squared equals 19. I could now square root each side. You're going to get x plus 4 is equal to, when you do this, you need your plus or minus in front of your radical 19. And then from there, if we were to get x alone, x would equal negative 4 plus or minus the square root of 19. Okay? So these are exact solutions. Again, you could have used the quadratic formula and you would have gotten the same thing. Okay? The fourth method is to solve using a table. So use table in calculator. Okay, but make note here that this is only going to be useful if we know we're going to have integer roots only. So this is really not a technique we're going to use that often, if at all. So only ideal if roots are integers. Okay? So if we were to go back and look at our first example, x squared plus x minus 6 equals 0, the one we were able to do through factoring, if you were to put this into y equals into your calculator and then look at a table of values, what you would see is that at negative 3 and then again at 2 for x, the y values would be 0. Okay, again, we're not going to spend really any time on that because it's only ideal, like I said, if we have integer values. Sometimes you might have one integer and then one non-integer, so it's really not an ideal technique. The last technique is to do it graphically. This is going to be something that we really try to encourage you to do, provided you're allowed to use a calculator, which you will be most of the time. So the last one here is to use calculator to solve graphically. Okay, so solving graphically. So let's take a look at x squared plus 8x minus 3 equals 0. Same one that we did back in example 3. We know the exact solutions were negative 4 plus or minus radical 19. So the way you do this is you graph it, okay, using your calculator. All right, and you want to sketch it on your paper, okay, as part of showing your work. So if you were to do this, you would see something like that. So we are after the roots, which occur here and here. So what you're going to do on your calculator, and again, you want to make sure you practice this, you're going to go to second calc, and then you're going to, once you're there, you're going to select the 0 button, which is number 2. So 0, alright, these are called zeros, right? We said the roots are also known as zeros. So you're going to have to move your cursor. If we're looking to find this one first, it'll first say left bound. So you're going to want to move your cursor somewhere to the left of your point, okay, which looks like it's above, alright, but it's really to the left of it. And then you're going to move your cursor to the right after you hit enter. It'll say guess, hit enter one more time until it tells you the 0. So this first one here, I'm drawing a lot of arrows around it. This first solution would be x equals negative 8.36. That's the 3 sig figs. And this other solution would be x equals 0.359. And again, try that on your own. You need to be able to do that. And notice if you were to do negative 4 plus radical 19, you're going to get this 0.359 number. And if you do negative 4 minus radical 19, you're going to get this other number, okay, rounded to 3 sig figs. So you're going to choose a method based on the form the quadratic is in, okay, and also whether or not you're allowed to use a calculator. Guys, if you are allowed to use a calculator, you should be using technique number 5 every single time. Unless they tell you have to do it algebraically, it's the easiest one to do. If they say you have to find exact roots, well, then you're going to have to use an algebraic technique. But if it just says to solve and you're allowed to round to 3 sig figs, you want to use the graphical technique.